All right, example 1.32 from OpenStax Precalculus, another average rate of change formula. So I'm going to, again, refer you to this average rate of change formula. Difference in the outputs of the function divided by difference of the inputs in the function. This time it looks like my function is called f, so this formula will fit a little bit better. The difference between this and the prior examples is in the prior examples my function was represented either with a table or with a graph. But probably the most common way to represent a function would be with a formula like I have here. So I'll work through this example. So the first thing you want to do is arbitrarily choose x1 and x2. Makes no difference whether you call this 2 here x1 and this 4 x2 or vice versa. It's totally up to you. But once you make that decision, you have to be consistent throughout the rest of the problem. So I'm choosing x1 to be equal to 2. So when I take my formula here, in the denominator, I'll have x2, which is 4, minus x1, which is 2. And up in the numerator, right here, I want to write what comes out of my function when I put 4 into it. So maybe I do a little side work here. Let's figure out what is f of x2. Well, f of x2 is what comes out of the machine when I put x2 into the machine, and x2 is equal to 4. So what comes out of the machine when you put 4 into it? Well, here's a little blueprint telling me what comes out of the machine when I put x into it. So all I gotta do is copy this thing right here, except everywhere I see an x, change it into a 4. So I got 4 squared minus 1 over 4. In other words, I got 16 minus a quarter. It's kind of annoying. So I guess if I got a common denominator here, I would say this is 64 fourths minus 1/4. So I'd end up with 63 fourths. A little bit annoying to deal with fractions inside a problem like this, but hopefully that's something you can handle. I need to do same analysis to figure out f of x1. Well, x1 I decided would be equal to 2, so I got to figure out what comes out of this machine when I put 2 into it. And when I put 2 into this machine, again copying the blueprint and changing all the x's into 2's, I get 2 squared minus a half. And that's 4 minus a half. And if I'm going to subtract fractions, I need the same denominator. So if you think about this as 4 over 1, you could multiply the top and the bottom by 2 to make it 8 over 2. The purpose in doing that is now I have a common denominator, so I can subtract the numerators. 8 minus 1 is 7, and leave the denominator alone to get 7/2 here. Now I have all the values I need up here. F of x2, which is what I'll write right here, is 63 over 4, minus f of x1, which is f of 2, is 7/2. So I get here. What do you do from here? I mean, I guess it depends on what class you're in. A lot of people would throw something like this into a calculator, although you'd have to be pretty careful with the order of operations and parentheses. If you're in my class, you don't have a calculator. What you want to do is recognize that you know how to divide a fraction by a fraction. It's a lot like multiplying fractions, but when you're dividing fractions, you multiply by the reciprocal of the denominator. But you're like, yeah, that's all great, except I don't have a fraction divided by a fraction here. I have a difference in two fractions divided by a difference in two whole numbers. But that's okay. What I can do is make this numerator here a single fraction. And the way I would do that is by getting a common denominator, much like what I did down here. If I multiply this fraction here by 2 over 2, I'm not changing its value. I'm just expressing 7/2 differently. I'm going to express it as 14/4, exact same thing. But the reason I'm going to do that is now I have a common denominator up here in the numerator, and I can subtract those fractions. Note that in the bottom, 4 minus 2 is just 2, so I just wrote a 2 here. 2 steps at once, I guess. When you're subtracting these fractions up in the numerator, if you have a common denominator, you just write that denominator, and then 63 minus 14 is 49. So I got 49 fourths over 2, but I'm going to write 2 as 2 divided by 1. And the reason I'm going to write it like that, kind of running into myself here, is, as I mentioned earlier, I know how to divide fractions. If I have a fraction, a single fraction divided by a single fraction, I can divide them. I couldn't have done that up here, but I can do it down here. And the trick is you multiply by the reciprocal of the denominator. So instead of making it 49 fourths divided by 2 over 1, I'm going to make it 49 fourths and then change it to a multiplication problem. But I can't multiply by 2 over 1, I have to multiply by 1 over 2. That's a little trick that's worth memorizing, that dividing fractions is the same as multiplying by the reciprocal of the denominator. Flip the bottom upside down if you want to say things really informally. When you're multiplying fractions, you multiply straight across. 49 times 1 is 49. 4 times 2 is 8. So I'd get 49 eighths. That's an irreducible fraction. I'd leave my answer just like this. Little commentary here. The reason that trick works, maybe you don't care why it works, maybe you just want to memorize it, and that's totally fine. But I like to know why stuff works. So several steps in here. Like when I changed 7/2 into 14/4, I multiplied the top and the bottom by the same number. And that's a nice property of fractions, that you can always multiply the numerator and the denominator by a given number and not change its value. 7/2 is the same as 14/4. So just like I can multiply this fraction's top and bottom by anything I want, I can multiply this fraction's top and bottom by anything I want. Right? There's one number on the top and one number on the bottom. And so I could choose to multiply the top and bottom by, I don't know, 7/3 if I felt like it. Wouldn't help at all, but I could. I could multiply by 7/3 here and 7/3 here and not change the value of this huge expression. Well, I'm not going to choose 7/3. I'm going to choose 1/2. And why am I going to choose 1/2? Because the 1/2 that's down here on the bottom will cancel out stuff really nicely. The 2's will cancel, end up with just a 1 here. And when you're dividing by 1, you don't even have to write it. So really what I'm doing is I'm taking this big fraction, I'm multiplying the top and the bottom by 1/2. All this cancels out, and what I'm left with is just 49/4 times 1/2, which is what I get to right here. You don't have to go through and show those steps every time. I think it's perfectly fine to memorize that division of fractions is the same as multiplying by the reciprocal of the denominator, aka change it to multiplication and flip the bottom fraction upside down. But the reason why it works is what I just explained. So I'll stop this example here.